Okay, good morning, everybody. Thank you, Isabel, Andreas, and Rodrigo for this motivating opening. My name is Mónica Aragüez, and I am project engineer and postdoctoral researcher in Tecnalia UPC, and it's a pleasure for me today to moderate part of this symposium. The two first parts are the track on SmartNet and the track on flexibility markets. So we have here the speakers for the track on SmartNet. Carlos Madina is the first speaker, so I will briefly introduce him. He's a research engineer for Tecnalia's Energy and Environment Division. He's an electrical engineer by the School of Engineering of the University of the Basque Country in Bilbao, and he has 15 years of professional experience in economic analysis of new business models in Europe. So I give you the floor.
Thank you. So, yes, thank you all for coming here and to have the opportunity to talk about this project, this SmartNet project. It is a 3-year project. We are now in the middle of it, so it's a good point to make kind of a break, a short recap of what we did so far and what we will do in the next year and a half. And we are 22 partners from different European countries, mostly located in Italy, Denmark, and Spain, which are the main focuses of the project. So first, I will give you a general overview of the project with some of the tasks that we did about the coordination schemes we defined for the TSO and DSO interaction, the analysis we did for the ancillary services in different European countries and for the future, the market setup we are trying to build up around this concept of the TSO-DSO interaction, and the ongoing work in the simulations to get the cost-benefit analysis for each coordination scheme in each country. And then I will make an introduction to the pilots, which will be later described also by Miguel. So the main idea is to define different architectures for an optimized operation and interaction between the TSO and the DSO, focusing on 3 countries and building an ad hoc simulation platform to perform a cost-benefit analysis for different interactions in the 3 countries. So first we started defining the different the different reference architectures, the coordination schemes, ancillary services, and so on. With that, we defined a network model, a market model, and an ICT model, which allowed us to build some formal specifications to create the simulation platform. In parallel, we started building some national scenarios, gathering the data for the 3 countries, taking into account regulatory constraints and so on, to run the simulations during the second half of this year and to perform the cost-benefit analysis next year. With that, we will get a return of experience, which will be complemented by the outcome of the 3 pilots in the 3 countries also. And that will allow us to provide some regulatory recommendations out of our experience. At the moment, we are developing the pilots, building up the simulation platform, and building also the scenarios. So we started defining 5 possible coordination schemes for the TSO and DSO. These coordination schemes are to procure the flexibility of resources located at distribution level. So the first one is the centralized ancillary services market model, in which, let's say that the TSO is king. He is the one managing the ancillary services market, which is a global market, including transmission and distribution, and the DSO is gathering all the flexibility, also from the resources located at distribution level. In this case, the DSO can pre-qualify the units or the bits, or even block the bits if they are creating some problems in the distribution grid. But they are not gathering any service for themselves. So this is more or less what is the present situation in many countries. A second model is the local ancillary services market model. In this case, the king is the DSO, who creates a local market to gather flexibility from DER to solve the problems in the distribution grid. And in addition, it acts as an aggregator of those resources to be able to provide services to the TSO. In the third model, we have the shared balancing responsibility. So balancing responsibility is split between the TSO and the DSO. And there is a schedule profile between, in the interconnection point between TSO and DSO, and each system operator is responsible for keeping that program. So the DSO opens a local market not only to solve the problems in the distribution grid, voltage problems, congestions, or whatever, but also to be able to respect that scheduled program in the interconnection point. A fourth scheme is the common TSO-DSO market, in which the TSO and the DSO collaborate to obtain the flexibility from the different resources located either at distribution or at transmission to get the best solution for the system in general. And the fifth option is the integrated flexibility market model, where TSO and DSO procure flexibility from DR, but in this case compete with other commercial market parties who also want to get the flexibility from DR. So these are the 5 coordination schemes we envisage in the project. If you want to learn more, there is a public deliverable in the SmartNet website where you can download all this analysis. Then we also started looking at the different ancillary services being provided today in the countries represented in the project. So we looked at Austria, Belgium, Denmark, Finland, Italy, Norway, Spain, to see the different ancillary services for frequency control, for voltage control, and also for other types of ancillary services. And based on this, we also made a survey of what the future might be for ancillary services. In SmartNet, we are focusing in the medium term, in 2030, where the winter package will be in full operation, so that we identified a number of services which are, we are used today, but are not widespread. There are some other ancillary services which are emerging or are only in some specific places, but we think that they might be widespread in the future. And some others which will be new services for DR, either because DR get a new functionality to be able to provide those services, or because they are completely new services. So again, this analysis of the ancillary services is also available on the website. Based on those coordination schemes and ancillary services, we started defining different market architectures, so that we want to have a market which is, in a way, tailored for gathering the flexibility from small units, but making in a level playing field for all the actors, but which doesn't create new constraints in the grid, and it doesn't make myopic decisions for a moment and not taking into account the next time steps. So we had to work in different dimensions in terms of timings, on bidding, on network clearing and pricing. And we made a number of proposals so that we propose to have a closed gate auction with a clearing frequency of 5 minutes, with a rolling optimization and a time horizon of 1 hour. Regarding the bidding, we will hear afterwards the progress we are doing in the presentation by David. For the network, we simplified the transmission network, but not that much the medium voltage network, so that we have a second order cone programming problem, a convex problem. And regarding the clearing algorithm, there is that let's say, balance between maximization of welfare or minimization of activation costs. And regarding the pricing, we selected to have locational marginal pricing for the market. Again, all the description of the market and the bidding algorithms are available on the project website. And now we are doing we are building the simulation environment, developing the simulation software, which is made in 3 layers: the physical layer, the aggregation and bidding layer, and the market layer, so that we take into account the constraints of the DR and of the network in the physical layer. With that, we create the bids in the bidding layer, which are sent to the market, and then the market sends back the results to the aggregation and bidding layer, who sends the activation signals to the physical layer. In parallel, we are building up the scenario. With all that, we will do the simulations in this second half to have the cost-benefit analysis next year, and that will be complemented by a laboratory implementation of different equipment to test the real-life performance of them. And that, let's say, that is the theoretical part, looking at 2030, but we are also doing some real-life implementation today under present conditions in the 3 countries which are in the scope of SmartNet. And the first one is this centralized TSO control in a high DR area in Italy. In Italy, in the last 10 years, there has been a huge increase of renewable penetration, especially photovoltaics, and this creates a number of issues in terms of grid operation, especially the power flow becoming reverse, so going out from distribution to transmission, and the need to forecast the production by renewables. Based on this, the Italian regulator has requested to investigate new possibilities to improve the electricity market in terms of allowing DR to provide services via aggregators, or to improve the observability of the TSO. So, taking that request by the regulator into account, we are developing this pilot in the South Tyrol area, in the northern part of Italy. Here we have, in this pilot, we have Terna, which is the Italian TSO, and also Madina, which is the local DSO, managing the distribution grid in that part. In this case, we are considering the centralized ancillary services market model, so Terna will be the one dispatching the units. But here we want to have a number of applications, the aggregation of information, so that Terna increases the observability of what is happening in the distribution grid. So there is an aggregation of information in terms of installed capacity and real-time production by different types of renewables, photovoltaics and hydropower plants particularly, and to be able to provide voltage regulation and power frequency regulation and balancing by generators both at high voltage and medium voltage. So the architecture is like this, and here we have these new units located in the distributed generators, which are connected to the DSO SCADA, And then the DSO aggregates all that information and sends it to Terna. At the moment, we are quite advanced in the definition of the pilot, so we made all the specification, all the software development, and we are finishing the installation of the hardware in the different DER. So we are 20 out of 28 power plants already equipped with the equipment to be able to run the pilot. We made the testing for everything except for those units which are still missing, and we expect to start the execution of the high voltage part in September and the low voltage part in October. So to have a full year experimentation until June, July next year, and make the reporting afterwards. The second pilot is in Denmark. It's a common TSO-DSO market with pool flexibility. And here the main concept is this smart energy operating system, which consists of putting intelligence along the whole value chain of the electricity supply, so in the TSO, in the DSO, in aggregators who get forecasts for weather, for load, and are able to transmit activation signals downstream. And in particular, we want to focus on these intelligent buildings, which here in the pilot we have this company Novasol, who is a renter of summer houses for holidays or for weekends, and they offer different services to their clients in terms of safety, security, energy, billing, and so on. And in most of their houses, they have an indoor swimming pool, which we want to control in this pilot. Here again, we have the TSO, Energinet, DK, in the pilot, also the local distribution company, which is Sudenergy, and also Novasol, who is the owner of the houses. So the pilot is located in the northwestern part of Denmark. We are aiming at having 30 summer houses. We have already 10. We are almost having another 10 this month, and we will complete the 30 summer houses in January next year. And here we will simulate a common TSO-DSO market, so both Energinet and Sudenergy will post their needs in a common market, where one will offer the flexibility of the summer houses. And that flexibility will be used to solve congestions at the distribution level caused by photovoltaics, electric vehicles, or heat pumps, to solve balancing problems for the high penetration of wind power, and all of it made through price-based control. So here the case is that we have the TSO and the DSO posting the grid status into a common independent market operator. This receives the bids by the aggregators, clears the market, sends the market result to the aggregator, and then the aggregator broadcasts price signals so that DER can react to that based on weather forecasts, load forecasts, and so on. At the moment, we finished the functional and technical specification for everything except for the market, which is taking us more than expected to create this new market for the two system operators. We will develop the software for the market and for the aggregator this month. We finished the installation of hardware in those 20 houses by now. We will do the testing in September and start the execution in October this year. And the third pilot is the shared responsibility with base station flexibility, which is in Spain, and which is managed by Endesa and Miguel, who will give you the details of the pilot.